you probably don't want to pick a specific database, of course I wish they would all just say, well, Postgres, well, everyone else can go hang, but they're not going to do that. So what but there's database agnosticism of, we will refuse to support advanced features of a database because for fear that somebody, having spent their first 2 years running on this database, will switch to this other one. And I think that's not being realistic about deployment environments. It's never, that was my joke about, it's not going to happen that somebody, at midnight is going to say, forget it, we're switching for underlying programs, database in production. That's, it's like saying, that's such a huge nightmare that the ORM level support is your least of your problems on that point. So, but yeah, actually having it something like a really Postgres specific ORM would be kind of cool. Of course, then there's two ends to it because all ORMs by their nature are very tied to the object model of a particular language. So you would have to have a Python Postgres ORM and a Java Postgres ORM, and that's a very specialized whack of code. Of course, companies do build their own ORMs, and they frequently do make those decisions. Yes.
I was going to say that ORMs do have optimizations for specific databases. They are not necessarily agnostic completely. If you use MySQL, they're going to use certain statements. If it's Postgres, they're going to change the syntax that they send.
Oh, absolutely. Some of them are just adaptive things where there's no real performance benefits, just what you have to do because every database has its own syntax. And some of them will take advantage of underlying database features. It depends on the philosophy of the particular ORM, how aggressive they get about that kind of thing. In the case like the Django example I gave, they were busily emulating, deleting, cascading, in the case that you were running on MySQL or MySQL without InnoDB or SQLite, and that's kind of, that's kind of broken. But unfortunately, it means that if you want to really take advantage of advanced features, not a lot of ORMs will be smart enough to switch to using Postgres full text search, or things that are very specific to a particular database. Yeah?
I really don't want to make a case for pursuing database agnosticism, but I do have to say that every job I've worked at the last decade has involved major database transitions where you decide that, we don't want to use Oracle anymore, we want to move to Postgres or something like that, and or a lot of writing glue code to tie together different RDBMSs, or seeing people work with Informatica and tools like that to do work around the fact that things are tied to the database. So I freely admit that it's not really practical to try to be agnostic of the database, but it's a lot.
No, of course it really does happen that you switch underlying database products. And if you're writing a packaged application that has to run across multiple database products, then you're in a different world. And you have a different set of constraints. It's like the EAB thing. It's like that's one of the few times that the EAB scheme actually kind of makes sense. But inevitably there's going to be it's how much this is a technical sort of a management decision, is how much are you going to pay for that agnosticism? How much is that worth to you? Are you going to, for example, go with ignore useful specific database features in order to allow for this transition in the future? And there's no one answer to that. I think companies can be or not companies, ORM developers can oversell database agnosticism a bit as a more common operation than it is. I mean, companies don't do this willy-nilly, and when you're going to make one of these transitions, it's a big deal, and inevitably there will be code that has to change no matter what. So, anyway. But yes, of course it does happen. Yeah.
I think the biggest selling point of the database ORM is not really getting used to switch from one DNS to another one, but rather it gives to application developers the ability to target the application to different vendors. So, for instance, I'm getting something on top of an ORM, and my clients are used to PostgreSQL or MySQL or another product. So I can build my application once using a abstraction layer, and then I can sell it to different.
Absolutely. That was sort of my package application comment. you're developing a packaged application as opposed to in-house technology that's going to, that you're putting in production locally, then you have a slightly different set of constraints, just like if you needed to build across multiple operating systems, or something like, or any of these. You want to support both BSD and Linux, then you're going to have other constraints. And that's a specific set of concerns. And then you have other concerns like how modifiable do you want the schema to be, or do you modify the schema, do you let people modify the schema in the field, or do you use the AV type approach to modify the schema? So yes, yeah, absolutely. Oh, yes, I'll get back. This is one of the things that we find that ORMs are a big victory, is that you don't have these selects and other small operations scattered through this entire code base. Frequently, for languages that are and interface libraries where it's still a problem, it means more resistance to injection attacks, because the ORM gives you a one-stop shop for cleaning the ORMs are great for that kind of thing. Absolutely. It's when you start moving outside the design center they start coming into blue. And I'm sorry, what was your?
No, I just want to add the optimization theme. I noticed that many ORMs lately handle custom optimizations not by resorting to LLVM or some real-time compiler parsers and compilers, but by saving cache the original query to a class or a file of this. Then you can see the actual SQL statement that is automatically generated, and you can intervene on that one. So if there is a cache file or a cache class, the application will use that. And
that's great, yeah. No, that's a very nice feature. It would be nice if more ORMs allowed you to do these queries as two-step processes, where you let it generate the query and then allow programmatic intervention. It's a little bit fragile because it constrains the ORM developer in the way they can. If you have something that really relies very deeply on the parse tree of a particular query, and that means the ORM develop the output of that process is suddenly becoming part of the ORM's API, and you might want to think twice about whether or not this. I'd hate a new version of the ORMs break all my code because the parse tree changed. Because the ORM developer got smarter about how to write a join or something like that. But in theory, there's a lot to be done there. I mean, one of the nicest things that Django did in the version before last was let you issue raw SQL queries, but still construct those as proper objects, and that was a big step forward. Because before that, you either had to manually create the objects or just use associative arrays as the output. If you did raw SQL, which meant there was this huge dividing line between the ORM world and the raw SQL world. And adding the ability to create proper model objects from raw queries was a big step forward. So, ORM technology continuing to advance has definitely had its place. It's just I'm looking for incremental, not revolutionary changes in technology going forward. Great, thank you very much.